Hi, and welcome to the first part of uFrame 1.5 Getting Started tutorial. This is going to be a primitive 2D platformer in a Western style. We got characters, some coins, some platforms and spikes. In this part, we're going to take a look at the initial setup, create uFrame project, create a few subsystems and elements, and finally we will code character movement. This is the initial setup of the project and it will be available for downloading. It's fairly simple. In my hierarchy, I got main camera, character, some world objects and some coins. On my main camera I got some GUI elements, as well as smooth follow script, and the target is set to a special object defined on my character. That is why camera always follows the character. My character is represented as two objects. The outer object holds the rigid body and the collider, as well as audio source. The inner one holds the animator, and it's dedicated to all the art defined on my character. My world consists of a few helper objects defining the visual look of the world as well as its bounds, and also I got some platforms and some spikes. And finally I got some coins under the coins object. At this point, I have absolutely no scripts defining any game logic or character movement, or anything else which could potentially affect my world or any entity. I have just imported two packages, uFrame Complete and Unity VS. Unity VS is not a requirement, but this will help if you are working with Microsoft Visual Studio. Now we will create a new uFrame project by going to Window, uFrame Designer. We don't have any uFrame projects defined yet, so uFrame Designer will allow us to create one. Let's call this one Running Guy Game. And the diagram will show up. In your project hierarchy, you will see that you got a folder generated called Running Guy Game. uFrame will store all the generated code as well as diagram files here. Before we actually start, let me rename this graph to main diagram. I will go to uFrame Designer and create a scene manager. I will call this one Level Scene Manager. And I will create a subsystem. It's going to be Level System. I will link Level System to Level Scene Manager and hit Save and Compile. If you look inside Running Guy Game folder, you will see that uFrame generated a few classes for us. Designer files are maintained and generated by uFrame. You are not supposed to modify those. However, working code is stored inside different folders. For now, we got code generated for Level Scene Manager. Now, I will prepare this scene to work with Level Scene Manager. For doing this, I'm going to create a few empty game objects. I will call one Game Manager, and the other one will be Scene Manager. For Game Manager, I will drop in Game Manager, and for Scene Manager, I will choose Level Scene Manager. Finally, I'm going to tell the Game Manager to work with this Scene Manager by linking those. I will save the scene now, and it's ready to work with uFrame. Now we will start designing character and character movement. I will go to uFrame Designer and create a new subsystem. It's going to be Character System. I will link it to the Level System. Inside of Character System, I'm going to create a new element. This is going to be Character. Inside of Character, I'm going to work with its properties, collections, and commands. Also, here I will define a view for the character. It's going to be Character Avatar View. Now I will create two properties. Movement intention and movement state. Movement intention is going to be an enum. And I will link my property to the enum. Movement intention is going to be dependent on the input, and that is why it's going to be a scene property, so I will link it to the view. Movement state is going to have its own state machine. I will call this one character movement state machine. And I will link movement state to this state machine. Inside of this state machine, I'm going to design a few states. One is going to be idle, another one is going to be move left, and the last one is going to be move right. I will expand my state machine to add transitions. Those are going to be go left, go right, and stop. When the character is idle and we're going to move left or right, we need to use those transitions here. And those will go to move left and move right respectively. When I'm moving left, at some point I'm going to stop and transition back to idle. But also, player may change his intention right away, so that is why I can go right from the move left state. And the same applies for move right state. Finally, I'm going to set my idle state as the default state by linking my state machine to the idle state. Now, when we have states and transitions, it's time to define some triggers. I'm going to use computed properties for those. Those computed properties have to be of type Boolean to serve as triggers. The one would be should move left. Another one will be should move right. And the last one is going to be should stop. I will link each of those computed properties to the corresponding transition. Finally, all of those are going to be dependent on my movement intention. So I will link movement intention to all of those computed properties. Something like this. Finally, I will tell this view that it is interested in the movement state by adding this binding. Actually, I should add movement state changed from state machine property binding category. And for movement intention, I'm going to introduce 3 items: left, right, and stop. And I can save and compile. In the running guy game folder, we got a few things generated for us: character controller, character view model, and character avatar view. So we're going to work with those. Inside the view models, you can define how your computed properties are being calculated. So here I will override three methods. They're called compute should move left, compute should move right, and compute should stop. For example, for compute should move left, I will just return if my movement intention equals to move left. And it is totally the same for the other two guys. Those computed properties are being recalculated every time my movement intention changes, because in my diagram I have expressed it by this dependency. And also those computed properties serve as triggers for my state machine, so once my movement intention changes, my state machine can change its state too. So here you can use any other properties to add some additional check-in, and if you want the computed property to be recalculated along with the other properties used here, you will have to specify the dependency on the diagram. We don't have any commands on our element, so we will leave controller as is. And we're going to work with the view now. As you can see, we got handlers generated here due to the binding to the state. But before we actually use those, let us add how the scene property called movement intention is calculated. For this, I will override a method called calculate movement intention. I will remove the base invocation. And if on my input object I got a key down, actually if I got the key pressed at the moment, and this key is A, I'm going to return left. If the key is D, I'm going to return right. And finally, if no keys are hold, I'm going to return stop. Now let's finally make our character move. So I will need a speed variable, which could probably come from the view model, but for now we'll leave it on the view. And I will need my animator object and my arc transform. I need to cache those. For this I will override a wake method. And when you use a wake method, make sure you override this one. In here, I will cache my objects, just like this. And finally, I will use my state handlers to actually perform some moving. So when we're moving to the left, I'm going to use fixed update for this, but I'm going to use observable this time. So every fixed update, I'm going to perform some moving. Something like this. And this one should be minus. But I also want to stop moving once my state is changed. So I'm going to dispose it with the property defined on my character called movement state property. And I'm going to do absolutely the same for move right state, but I'm gonna use positive speed. It is going to move my character around, but it's not going to produce any kind of animation. So I will need to add a few things there, like changing my animator state and also rotating my arc properly. State 1 stands for running. So on the idle state, I need to change it back to 0. Finally, I'm going to add character avatar view on my character object and hit play. And there we go. Our character finally moves.